Hello, we are group three, and I'm Casey here with Nash, Jake, and Isaiah. And our project was the email phishing detection Outlook add-in called Fishnet. This can be used on both the online and desktop version of Outlook. Today we'll be covering a quick little introduction, a refresher on what our project is, and Nash will talk about design, and then Jake will do some testing overview, and Isaiah will give a quick demo, and then we'll talk about what went well and what didn't go so well. So Nash will give us a little bit of rundown.
Hello, uh, Nash here. First, I'm going to talk about why we chose this project and its inception. Uh, First, we were drawn to the AI Bagel Time project with SBS Cyber. We were excited about working with a company in the cybersecurity industry. Um, we were also excited about the extra credit opportunity, of course, and we thought that the Outlook add-in really aligned with our skill set and our interests. So I'll discuss the technology used. Like many of you, we used Git and GitHub for our version control. Uh, some of us were pretty experienced with GitHub, which was nice. We were able to bring the others up to speed. And then the Microsoft Outlook dev environment. Um, as Casey said, the uh, our project works in both the desktop app version and the web app. Just a handy side effect because we built it in JavaScript with the Node.js framework, um, which JavaScript, if you're not familiar, it's primarily used in web development. Um, with that in mind, we used a testing suite. We used Jest, Chai, and JS DOM. And then let's take a look at the UML documents. We can bring those up. Perfect. So yeah, pretty straightforward. Our plan was originally to um, sort of abstract the AI model to better suit whatever SBS's needs were. Um, as we dug into our own research and discovered more about the limitations of AI models and of the environment that SBS uses, uh, we decided not to abstract that after all. Just something that happens when you're working with tools, especially tools like Microsoft Office Outlook. Uh, anyway, I think we'll take a look at the project now in action.
All right,
Uh,
hello, this is Isaiah, and I will be in charge of actually kind of showing you guys a good demo of the project and everything. So first things first, I'm going to get it started up here. Um, Normally, when the user actually uses our app, they wouldn't have to do this npm run start, as I mentioned in my last presentation. This is simply what we have to do for back-end development. So you can see it's kind of getting it started up. I am specifically going to be looking at the web app version just because that's the version I normally use and it works best for me. Um, so once it's all done, you can kind of see that it gives you a message that it is ready and started up. So we'll go to the web app. I'm just going to go to my quarantine folder. Oops. This is actually like real phishing emails that I have received that were just automatically put into quarantine. So I will kind of show you how it works. You just go to this apps page here, which is where you'll find all of the Outlook add-ins. You hit it, you see Fishnet, this is our logo. You'll just hit that, show task plane, which is where all the magic happens. And then you can see it runs automatically, which I really like. That was a specific feature that was not on our feature list, but it ended up making it into one of our features because it was something we ended up noticing that we should add this. So anyways, you can see that it gives us a risk confidence score, suspicious elements, and then an analysis. You can see here that for the risk confidence score, it gives you a percentage score and then it dynamically colors the score itself depending on the value of the confidence score, just using some basic like React and JavaScript magic. So yeah, you can see for medium, I can't remember the exact ranges I chose, but for medium, it's like an orange, and then for high, it's red, and then for low, it's green. And anytime you get like an email that is somewhere around the medium range, you definitely should be weary of it being a phishing email. And I was actually looking through this email earlier. It does kind of look like it's phishing email because it looks like it's from DSU, but they show a Gmail email, which normally means it's phishing, but I'm fairly certain this is an actual email. So the AI did a great job at identifying the uncertainty because it should be uncertain with this email, especially with a lot of these grammar mistakes and stuff. So yeah, a medium score is probably exactly where we want it. So we are all pretty happy with how the confidence score ended up turning out. And I am particularly happy with these suspicious elements because it does do a really good job at identifying the parts of the email that are legitimately suspicious. And then you can see the analysis here, which is just kind of a basic paragraph of what it thought made it phishing. Um, so that's that. I'm going to show you guys a couple different emails so you can get a better idea of how it works. Um, so you'll notice when I selected a new email, it actually closed the app, but that is why we have this pin feature here, which means every time you go to a new email, it's not going to just close it. And that was specifically Nash's doing. It's one of my favorite features because it just makes using the app super, super easy. And then I did specifically choose this email because it's obviously not a phishing email. So you can see the suspicious element um, section was actually completely removed because there wasn't any. So our AI does a really good job at communicating with us, and we handle a lot of the cases so that we're not adding stuff that doesn't need to be there. And you can see for this non-phishing email, it did a great job at categorizing it as low. And then I'm just going to show you guys one more where it's red, hopefully. We'll see. Sometimes it does take a second. That is one of the downfalls of this model. Um, so this one was most likely phishing, despite that fact it did categorize it as low. So obviously it isn't a perfect model. It doesn't work perfectly, but it still does work very well. And so that's about all I wanted to show you guys for the demo, just because you guys have already seen it. I'm more interested in showing you guys the good stuff, the code. So this task plane .js file is essentially where everything happens. This is where we connect to the AI. This is where we receive responses from it, where we parse the string and clean it, and then where we display it onto this taskplane.html file here. So I'll kind of take you through this. So first things first, this is kind of how we import the Google AI SDK. You can see we also have the API key, but that is securely hidden from GitHub so that we are not just exposing that onto GitHub for security reasons, of course. And then first things first, this is kind of what starts everything. This is a function, or this is kind of like an event call where when the app itself starts up, it'll run this, which will then pull up the app body. It hides the side message, and then it actually runs right away, which is this function way down here. And then I guess going even deeper, I'm going to kind of show you guys our prompt engineering here. So immediately in our run function, just give me a quick second. You can see we run this analyze call here, which will call this analyze function up here, where we give it the email content and then any metadata that we want to give it. And then from there, we actually connect to the Gemini model that we're using, and we're using the 1.5 Flash version, which we ended up finding is probably the best version that we could use. It hasn't cost us any money, which is nice. So the AI model has worked pretty well. But once we give it the email content, we send it this prompt where we specify that we need a confidence score, the elements, the reasoning. Specifically, we also talk about the objects that we want to receive back. So we want to receive an integer, an array of strings, and then a string explaining all of those things, which ended up not working very well, but I will get more into that later. And then here you can see our example response, where we actually give it a good example. So here you can see we actually connect to it, and then we grab its response, and then we we return the response in text. And then we also have some error handling here just in case, because the Gemini model is pretty often overloaded, which actually stops our program from running. So that is a big problem for our program. And then after that, you can see we also have to clean the Gemini response because it gives us a string back instead of an actual JSON object. So you can see what we do here is we have to remove these like weird backticks that it adds to it, and then we have to remove the JSON letters in it, and then we have to remove the backticks at the back of it as well. And then after that, you can see we also have to remove like white spaces and new lines. This is kind of where we remove the white spaces from the front and then the white spaces from the back here. And then once we have successfully cleaned it, we can use this JSON.parse to actually turn it into a proper JSON object, and then we just return that. And then from there, it's all pretty basic. You can see we put it into this variable called cleaned. If that doesn't work, we do throw an error out just in case. And then you can see here with this new cleaned variable, we are able to, I guess, display it like you would with any sort of JSON object in JavaScript. And so you can see we have like conditional JavaScript that changes which CSS element we use depending on a specific value for the confidence score. This is what makes the dynamic coloring work. Very, very simple CSS, but also very nice to have, or JavaScript. And then looking at this is also what makes the suspicious elements disappear. If the length is not greater than 0, it will not do any of this. And then right here is where we paste the reasoning. And then finally, we just insert that into our inner HTML. And so, yeah, that is basically how our whole program runs. We do have a lot of different CSS kind of down at the bottom. Some of it is auto-generated, but most of the magic occurs between this CSS and kind of this JavaScript here. And so, yeah, that is basically all that I have for you guys in terms of like coding and the demo. Next up, we are actually going to move on to the testing, and Jake will be taking care of that.
Hello everyone, my name is Jake, and I'll be going over some of the testing and testing philosophy that we implemented in our project. When we started the project, we knew that we wanted to have a small, maintainable product that we knew that the business would be able to utilize right off the bat. So we knew that testing had to be an important element of our development lifecycle. To do that, we use Jest, which is a very popular JavaScript testing framework. I think it's developed by Meta, and it's particularly well suited for testing React and Node applications, but I think it works good for any JavaScript code, to be completely honest. We started using Chai as an assertion and mock framework, but it didn't work really well with Jest, so we actually moved to Sign-On. And we mostly use Sign-On for the mock and stubs, while using the Jest assertion still. This is particularly important because when it came to our unit tests, you're not able to like really predict what you get back from the model. So we had to use this concept called mocks to basically like imitate what we would be getting back from Gemini. This actually worked pretty well. And one of the main reasons we did choose Jest as well is that it uses sort of a hierarchical like unit test structure, and that you have these like quote unquote buckets that you can put your like individual unit tests in to keep them very organized. And we will see that once we actually run the tests. But another thing I wanted to touch on was how some of the difficulties we faced when implementing our unit tests. The first major setback we had was getting all the various products installed properly. I think it took us a little over a week to get everybody on board and have the testing framework working properly. And then the other big issue we had, which I think leans a little bit more on why unit tests are important, was that we had a merge conflict that kind of broke all of our previous unit tests. And that was because whoever merged it in didn't have the unit tests working properly and weren't able to actually test before they merged their changes into our main branch. I think this really goes to show the importance of unit tests because like the idea behind unit tests is that you run these periodically through development so that you know if your changes break something or not. And that was the one thing we were trying to avoid. But all things considered, I think the tests worked out really well. We have 10 tests in total, and we got all of them to run properly. So now we'll take a look at what it looks like when we actually do run the tests. So as you can see, we have this hierarchical structure where we have our main bucket, so to speak, which is basically the like root level testing place. And then we have the three main chunks of our code, which is the analyze, the clean Gemini response, and run. We were able to neatly put unit tests into each one of those. And it's pretty convenient that it shows a little check mark that says if they pass or not. I wish we had a broken test or a test that wasn't passing, because we will show you that too. But fortunately, we had all the tests passing. And I think it really made our product very usable right from day one. Now I'll hand it off to Casey.
Hello, it's me again. Uh, we've been going over the good and the bad stuff a lot over our Phase 4 presentations over the semester, so I'll cover these pretty quick. For the good, we hit our MVP with some time to spare, so we were able to add stretch features. So this means that we were successfully achieved our AI email analysis for phishing for the Outlook add-in as per SBS's request in AI Bagel Time. This also means that we successfully displayed our confidence score, information about it, and added some dynamic coloring for the red and the orange and the green. So we were pretty happy with how everything looks and functions. As you could see, there was kind of a lot that went into it. And then for what went bad, we were not able to work with any AI students, which means we had to go and find our own AI model. And this means that we couldn't make the program run on our local network because we had to make API calls to the API. And also, SBS was not easy to communicate with. I don't feel like there was a lot of buy-in from them because we had set up one meeting with them where we got some requirements and more of an idea of what we were doing, but we were also instructed to steer clear of making encryption one of our features, even for as a stretch feature. So this means that the company we're working with will have to connect their own locally run API so they can use it safely. And I think that is all we have today. But thank you for listening, and we had a good time, fun time working on this project.